Radio TV phono nut here, and we have a rather sad looking entry level 5-tube Philco Tombstone. Well, I better not say entry level. I think there was one lower than this that just had the standard broadcast band. This one has the standard broadcast and shortwave band, but this is a fairly common set, and it's seen better days. As you can tell, the chassis has a good bit of surface rust on it. This set was stored in a damp environment, obviously. The brace on the cabinet was loose and had fallen down inside the radio. Fortunately, it was still present. So I'm in the process of trying to glue it back together. I don't have enough bar clamps. That's something I need to invest in, so I ended up having to glue this side on first, and then I was able to glue the rest of it on, and we're waiting on the glue to dry. Somebody has replaced the power cord at some point, although the plug area looks a little bit hinky. The filter can is missing, or at least one of them is, so that tells me that somebody hacked in a replacement under the chassis. I think just for fun we're going to plug this thing into the dim bulb tester and see what happens. This is really one of those sets that, and as crusty as it is, we really don't care if it blows up or not. Alright, we're at about 70 volts. Let's turn it on and see what happens. I got a little current spike there. And of course the light bulb will take the brunt of it if anything shorts on us. Right now we're not drawing excessive current, and we'll let it just sit there for a little while like that. I think we're probably developing B+, but we're not drawing a lot of current. That's with the rectifier out. And that's with the rectifier in. The bulb is glowing a little bit, and we're at a little over 100 volts AC input. And I'm hearing a little pop in the speaker every now and then. I hear a very faint hum when I touch the grid cap of the first audio tube. It's so faint that I doubt the camera is even picking it up. Our output tube is barely warm, which means it's not conducting. Well, I pulled the 6F6 tube and our current stayed basically the same. This looks like a very high hour tube too. Looks like it's got a good bit of burn off on the top. And it looks like an original tube. So, alright, our plate and screen voltages are around 88 volts, which is low, but I would expect that considering we're running this through a light bulb and considering the filters are probably leaky. Now when we move over to pin 5, our control grid voltage, we have 40 volts DC, so we have an extremely leaky grid coupling cap, which most likely cremated that tube. Alright, the 6F6 passes the shorts test. What about quality? Well, it's weak, but it should probably still be usable. What about gas? Well, low end of the bad range, kind of borderline, but I really don't trust the gas test function on this tester anyway. Alright, it's slowly climbing up into the green the longer it stays on, so we might can use this tube. Alright, I'm just going direct with the power supply, no bulb. We're at about 70 volts AC input. B+ is about 107 and slowly rising. When it peaks out, I'll give it a little more juice and let it slowly rise. and then when it peaks out again, I'll give it a little more juice and let it slowly rise. I'm trying to reform these capacitors here. And I know this is a bit unconventional, but I thought we'd do something a little different this time, as in try to diagnose as much as we can with the chassis still in the cabinet, and possibly get as much out of this radio as we can with the chassis still in the cabinet. And something that makes this a little more difficult is this is a 5Y4 rectifier, which has a different pin out than a 5Y3, so I don't have a solid state plug-in made up for this particular type. And I dug up an old dud tube to sacrifice the base from. We're going to make a 5Y4 plug-in solid state test rectifier, so we have our two pairs of two diodes in series for each pair. Technically we don't have to put two in series, but just to give a little margin of safety, then we will do that. And here's our 5Y4 solid state test rectifier, complete with a convenient test point to clip on to. Now, I've said this in other videos, I'm going to say it in this one. Do not use one of these solid state plug-ins for general use, because your B plus is going to be significantly higher than normal, and that's eventually going to cook something. Now, for testing under controlled conditions, this is fine, but if it had a tube rectifier originally, then it's best to stick with a tube for regular use. Now, the reason we want to use a solid state rectifier for testing purposes and cap reforming is because we can start out at minimal voltage and have B plus voltage developed, whereas if we had the tube rectifier in place, we'd have to input probably 50-60 volts AC before we even started to get any emission out of a tube rectifier, and then we would probably have too much B plus to start out reforming a cap. So let's see. Well, it would help if I plugged the radio in. Alright, about 15 volts AC input with no bulb. We have 53 volts B plus and rising, so we're going to let that peak out, and then whenever it peaks, we'll crank the AC up a little more, let it peak again, crank it up a little more, let it peak again, and hopefully we can reform these caps good enough for testing purposes. Well, that was weird. When I dumped the camera into the computer, I went back to review the footage, and it didn't save the clips in the correct order. For example, the intro was way down at the bottom, so I had to go through all of that and rearrange everything, and it's done that before. I don't know why it does that, but it has done that before, and it is a bit of a pain in the butt trying to do. But anyway, we're still with a solid state rectifier. We're up to about 125 volts B plus. It looks like it's, well, it may be trying to go up a little higher. Let's let it sit a minute or two. Well, I guess that's about as high as it's going to go for now, so we're going to increase the AC input a little bit, and we are going through the 100-watt bulb. Alright, so we'll let that sit and do its thing for a little while. We still don't have enough AC input to provide enough heater voltage for the rest of these tubes to start emitting. Now, when reforming a capacitor this way, if you see the B plus voltage start dropping, there's one of two things taking place. The first possibility, your tubes are starting to get hot enough to go into emission and start drawing current. Number two, you're rushing things a bit, and your filter capacitors are becoming leaky and choking down the voltage. Now, you can easily eliminate number one by removing the tubes from the set. No tubes, nothing there to draw current except a leaky filter cap. But if the case ends up being number two and your voltage starts dropping, then like I said, you're getting in too big of a hurry to reform, and you need to back off on the input voltage some and take your time, if you haven't already damaged the cap beyond the point of reforming it. See, this was at 135. It's dropped down a small percentage, so we probably don't need to push our luck here. The small variations you can attribute to, or let me rephrase that, small decreases in voltage you might can attribute to fluctuations in your line voltage, but if it starts dropping drastically, like more than a few volts, then one of those two possibilities that I just mentioned is taking place. And it looks like this has jumped back up to 135 and slowly creeping up. We'll let it sit a few minutes. Come, there you go, 136 volts. Just to clarify, reforming a cap this way, it could take the better part of a day to do this, so find you something else to do while you're waiting on the caps to reform, and just come back and check periodically, and if the B plus voltage is peaked out, then give it a little more AC and just continue the process. Going off track a bit, we can tell that speaker cone has some missing paper, which is really no surprise given the conditions this was stored in. And the thing about Philcos from this era, they like to use oddball speakers, not standard 6-inch or 8-inch or 5-inch or 10-inch. Well, they'll use something like a 7-inch or a 7.5-inch, which makes it kind of difficult to mount in a more conventional size speaker if you have to. It can be done, but it can be a bit of a pain in the butt. And seeing as how this speaker uses the field coil as a choke for the power supply, you kind of want to try to keep it original if you can. Yes, there's workarounds to get around that field coil if you have to replace it with a PM speaker, but it's best if you can keep it original. And also, I think some of these older original speakers sound better in the radio in which they were meant to be attached to than some modern speaker from China is going to sound. Well, I think I pushed my luck because I was starting to smell something overheat. So I think the time has come to pull the chassis out of this and go from there. Here's your first look at the front of this. Again, not the worst, but not the best either. And we can tell that whoever had this out last mismatched the knobs. They put the tuning knob where the volume control knob is supposed to be. And of course there'll be at least one of these knobs that's stuck on so tight that it won't come off with ultimate ease. And I think we just lost the keeper out of that one. Well, for once, something fell off, hit the ground, and didn't bounce into oblivion. And I guess whoever worked on this thing last must have thought that chassis mounting bolts were optional because there was only one out of the 5 still in place. Actually, what I think was heating up is this Bakelite block condenser that's the chassis line bypass capacitor. I see one electrolytic here that's been replaced at some point. There's one right under here that's been... Okay, that capacitor is a bit warm too. So this electrolytic that somebody hacked in under here and this line bypass cap is an issue, and it looks like somebody recapped this back in the 50s using these crappy red molded plastic case paper capacitors that like to short. Alright, we very crudely have another cap tacked across that one that was overheating, and I don't want to go to any trouble to permanently mount parts until I see if this thing is salvageable. We can see this thing is very rusty, and as common as these models are, unless you just were just itching for something very labor intensive to do, you would probably be better off and cheaper to find a better example of one of these and just restore that one and use this one for parts. And this old electrolytic that was heating up, we have an ant there, looks like, through the viewfinder. We can see it's already had crust leaking out of it, and that doesn't look like recent crust either. That's some pretty old crust. And now this capacitor up top that also appears to be a replacement is getting a bit on the warm side. I think I might have jumped the gun on thinking this Bakelite block was heating up. I think the capacitor that was next to it that was heating up was radiating so much heat that it got the Bakelite block condenser warm, so maybe it's not fixing to blow up. Alright, I cranked our AC input down to get lower B+. We're running about 148 B+, and I'm just going to let it sit a while and try to reform this other cap, because as crusty as this is, I really don't want to do any more to this than possible to see if it's going to play. Yeah, I punched in 37610 Philco on eBay and just to see what's there, and this one here is suffering from a decimal point misplacement syndrome. $349.95 plus $27 shipping. Tombstone turns on and hums. So yeah, we know what's wrong with that one. And we have the console version that looks like somebody's put some red grill cloth in it. $600 bid, or if you just have to have it right now, $900. Buy it now. Plus $80 shipping. I'd like to see somebody ship that for $80. That's not a 37610. That's a 41-231T that they want the low bargain price of $1,500 for. Here's another 37610 console for $600, pickup only. And then vintage radio lot, untested, local Southern California pickup only, $110. Buy it now. That might be the only one that's halfway reasonable, but if I were to look at them, it might really not be reasonable, because a lot of these are ones that are just rust buckets. It's had all the tubes stripped out of them, or it's sets that someone has determined has major problems, not worth repairing, so they bundle them together and stick them on eBay and hope for a sucker to buy them. But like I think I said earlier, these 37610 Tombstones, they're not all that scarce. And they use that same chassis in a Tombstone and a Cathedral and a bullet-shaped table radio and a console. It was a pretty common chassis. Alright, we've let this thing sit for about 45 minutes. Our voltage has jumped up to about 178. What was it, 160 something before? But this cap is still a little bit warm to the touch, and we don't want that, so we're just going to let it sit a while. And when that cap cools off, if it cools off, then we'll raise the voltage some more. I bet this is probably the only antique radio video on YouTube where we have clamps on the cabinet while the speaker is still in the cabinet and the chassis pulled out and trying to resurrect it. Alright, this capacitor has cooled down, which is a good sign, and our voltage has climbed up a few volts. We're up to 183 now, so we'll slightly increase our AC input here just a little bit. About 192 volts B plus now, so we'll just let that chill out for a while. Yeah, some caps reform faster than others, but this one here is being very slow. Very, very slow. Well, this capacitor seems to be reforming okay so far. It's just taken a very long time to do it. Alright, it's another day, and I'm just really not having any luck getting this cap to reform. Some of them are just so bad that there's just nothing you can do. I'm not getting any reception via the signal tracer at the grid of the first audio tube, but I'm getting a little local oscillator action here, and we can check that by turning on this transistor radio up close to the set and tuning through the dial on the radio, and I should hear some action in our transistor radios. Alright, I'm going to sit the camera down because I can't do this while I hold the camera. Right now we're at a point where I hear a little action on the transistor radio. So let's sit this down a minute. So we're getting some kind of oscillator activity, but that's about it. However, when I place the transistor radio next to a properly working radio, we get more action as we tune across the dial on our tube radios, which we were not getting on the other radios. So the oscillator in the other radio may be working to some degree, but I don't think it's working properly, because there's only a couple of spots on the dial where we get activity, whereas on this radio that works perfectly fine, I'm hearing all kind of activity on our transistor radios as we tune through the dial. So that's an easy way you can check the local oscillator in your radio. If you have a small pocket transistor AM radio, place it as close to your test radio as possible and tune across the dial on your test radio, and you should hear what you're hearing now in the transistor radio. Here's our offending capacitor, a dual section Aerovox that looks like it's probably dated the 40th week of 1956. I don't think this was made into the 60s. And it's two individual capacitors that do not have a common ground. So our positive is red. Well, let me make that a little clearer. For our first capacitor, our positive is red, negative is black, 8 microfarads. Second capacitor, positive is green, negative is yellow, 8 microfarad for that too. So we will just temporarily connect a couple of capacitors into our leads that we cut off and see what happened. Alright, I tacked in a grid coupling cap for the output tube, and that got rid of that positive voltage that we had. I also tacked in this final electrolytic that's the screen filter for the oscillator and mixer tube. So let's go put the 6F6 back in here and see if we get any kind of audio. Alright, I've reinstalled the 6F6. I'm not getting much current draw at all, and our audio section is basically dead. Alright, I didn't have a 6F6 handy. I had a 6V6, so I just plugged that in there. We're getting a little more current draw, and I get a buzz now whenever I touch the grid of the first audio tube. Alright, I went back to the 6F6, the original, and I'm now getting a buzz at the control grid of the first audio tube. Maybe it wasn't seated and the socket as well as it could have been, but the buzz we're getting is not as stout as what we were getting with the other tube, but at least this tube does have some activity now. Alright, we're off the bulb now with the filter caps replaced and the coupling cap for the output tube replaced. I think we're pretty safe. Now I'm checking some voltages. We're going to start on the IF amplifier tube. That seems to be the only one that's easiest to get to. Schematic calls for 270 on the plate and 90 on the on the screen grid. So instead of, no, actually I think it said 230 on the plate. I'll have 220 on the plate. I have to go look again, but 305, that's real high. Makes me think that tube's not conducting. Now looking at the screen, they want 90, and we have 42, so that is low. Okay, even though our voltages are off on the IF amplifier tube, and that could be because they specify a 1000 ohm per volt meter, and we're using a high impedance digital meter, I'm blowing a signal through the grid of the IF amplifier tube, and it's coming in loud and clear. So now we're going to move back to the control grid of the oscillator and mixer tube and see if we get some. And we're getting it, going through the grid of the oscillator and mixer tube, so that confirms that pretty much that our local oscillator isn't working correctly. I told you we were getting something there, but we weren't getting the results that I was looking for. And there we go. It is playing. What I did is the plate cap, the control grid cap on the oscillator and mixer tube seemed a little crusty. I just moved it around on the top cap of the tube, made the connection a little better, and viola, it started playing. Nope, I stand corrected. It wasn't a bad connection. It's the fact that I still had my signal generator lead clipped to the control grid of the oscillator and mixer tube. So we were bypassing the antenna coil and blowing a signal directly into that point. So either we have a bad antenna coil or possibly dirty switch contact on the band switch or something like that. And now we're not getting anything even with the signal generator lead connected to the top cap. So it was fun while it lasted anyway. I guess what we need to do now, since we know the radio is at least capable of playing when it wants to, is try to figure out a way to mount these dangling filter caps somewhere so I can sit the chassis in its upright position and play around with the top side some. Well, as it happens, a terminal strip will bolt down to the original spacing where the original can capacitor clamp was. So I think we're just going to mount our new capacitors up on the top side here. Now, let me clarify, if this wasn't such a rust bucket, if this was something that I was going to do a more proper restoration on, then I would figure out a way to put them under the chassis. But since this is what it is, I'm really not too worried about it, and I think this will be the simplest way to do this. Alright, this looks a little jake-legged, but at least everything's stable now. We put one terminal strip here to mount our two B+ filter capacitors, and oddly enough, the spacing was correct for that terminal strip, but not for this one down here that I used to mount the bias filter capacitor. So this resistor, everything that was just all sloppily soldered and dangling under the chassis, I extended the lead on this resistor with some solid wire from some scrap resistors, put heat shrink over it where it couldn't short to the chassis, ran it up here and soldered it to this terminal strip as well as the other leads that needed to go to this terminal strip, which connect back to the positive terminal on this capacitor here. And then our negative end of this capacitor connects to the back here to this big tapped wire wound resistor here for our bias supply. What I probably need to do is dismount this terminal strip before I'm done and sand this off really good where it's rusty and just solder this end of the chassis. It's really not going to go anywhere, but it would just be a little bit better if this end was secured too. Now, we're back where we started from, so now we need to look closely at that oscillator and mixer tube and the grid cap lead, because I think that may be where a good bit of our problem is. Alright, so whenever I clip the signal generator lead to the top cap of the oscillator mixer tube, we get reception. When we unclip the lead and clip an antenna on the designated point, we get no reception. So we need to look at our antenna coil here. At first, I think I mistakenly said that this radio only has standard broadcast in one shortwave band. Well, that's actually false. It seems the band switch was stuck. This actually has standard broadcast, the old police band, and a shortwave band. As we can see, we have an antenna transformer for our standard broadcast. We have another such item for the police band, and then a third such item for the shortwave band. And with an antenna connected to the external antenna terminal, there didn't seem to be any activity on either band. So there's not much here. We have this elaborate band switching assembly here, and we have the coils, and that's about all there is to this. So we need to clean our band switch. That would be a good place to start, and then check the continuity of these coil windings, and hopefully the latter isn't the problem. I cleaned the heck out of this band switch, but unfortunately that didn't solve the problem. Now, looking at the schematic, I should be able to show continuity between these two terminals here on the left of the antenna terminal board, and this terminal to the extreme right on the antenna board. If that checks out, then that tells us our switch and our primary winding on our antenna transformer is okay. So let's do that now. Alright, I'm reading about 19 ohms across the two leftmost antenna terminals. Let's see if we read anything to the okay, we're reading something to that terminal as well, so that tells us our primary winding is okay. These terminals are so rusty and crusty, it's hard to get a good reading there, but at least we have continuity. And I get a reading on all three bands, so our primary windings for all three coils are okay. However, our resistance readings here seem to be a lot lower than what I was getting on the ohm meter test just a moment ago. So we might need to look into this further. And then we need to check our secondary windings as well. So on those, 6 ohm for the standard broadcast secondary, 0.5 ohms for the police band secondary, and less than 0.1 ohm for the shortwave band secondary. Now I sprayed the heck out of that band switch, and we're now getting some shortwave with the antenna connected to the correct place. Identity, are you listening? And then you record. Well, there's Brother Stayer. Repented and Jesus. Other shortwave band sounds dead as a doornail, except for a little something right there that's like it's trying to pick up something. But still nothing at all on the standard broadcast band. So it seems like we have 2 dead bands and 1 active one. Unfortunately, it looks like the secondary winding on this antenna transformer is open, and it appears that somebody else has already been in here bumbling with this. If we look right here, we see this terminal has been broken off. There's a piece of the wire stub there. This is disconnected right there. So I think what I'm going to do is I'm going to find an old loop antenna, and we're going to try to bypass that antenna coil, and this will be just for our standard AM broadcast only. Now, if this was a better example of this radio, I would go to better effort to try to fix it correctly, but since this is what it is, an old rust bucket, then if we can get it to play satisfactorily on standard broadcast, then we're just going to leave it at that. We have this loop antenna that came off of a junk RCA radio. We have one end connected to the top cap of the oscillator and mixer tube, and then we have the other end connected down here to the AVC line. That's like you would see in, say, a normal AA5 radio with a self-contained loop, and it's doing pretty good here.
Wounded Warrior Project.
For Kamala, Republicans are voting for Trump. The people that
Well, we're not picking up 670, but I don't expect a miracle here.
Arms trying to wrap Brett Baer up, cutting the interview short because they knew she was bombing. The only reason you pull a candidate away from an interview is if you know...
Okay, we're going to let this play a little while, and if nothing drastic happens, we're going to figure out a way to permanently attach this.
At least 4 Kamala Harrises.
And then we're going to let it go.
During Donald Trump's administration...
I ask her a question, and she says, let's go back to Donald Trump. Donald Trump. Donald Trump. They can't take responsibility for the crap that they cause themselves, so let's just go back to Donald Trump, and we don't have an answer for, or we don't want to give a true answer as to why things the way they are. Let's just blame it on Donald Trump.
I mean, that's so embarrassing. That's so bad. He's asking her about her and Biden's Iranian policy, and she wants to pull out her talking points about Trump. That's all she's got. And in her mind, and in the Kamala world, in those of you supporting Kamala, you think that's going to be enough, that she's just not Trump.
All right, the radio is back together and playing. We'll go look at it in just a minute. I did not connect our antenna directly to the grid cap here. Instead, I connected it over here to the other side of the band switch that pertains to the section that switches in that would normally switch in the secondaries of these antenna transformers to the grid cap, so that way we can connect a long wire antenna to the radio's antenna terminal, and we should still be able to get something on that one shortwave band that's active. We'll check that out after dark when reception comes in better, so we can at least hear Brother Stair if we choose to do so. So we connected our antenna between this point on the band switch and then down here to the AVC line. Where is it? Where are you? Okay, yeah, the AVC line right here to the other side of this 1 meg resistor here. The other end of that 1 meg resistor connects over here to the one of the plates on the detector tube and through a capacitor back through the IF transformer. That's kind of a weird way of doing it, but that's the way they're doing it here, so that's the way we're going to do it. So, radio's working, and we're probably just going to call it a day with this one. So our AVC line goes back down here to the bottom of this, one of the sections on the band switch. And then it also connects to the secondary, low side of the secondary winding of this IF transformer here, the first IF transformer, but we'll go out and listen to the radio in just a moment. It does pretty good, and as far as alignment, I tried to tweak this trimmer right here, this number 4. It didn't do anything for it, so I left it alone. The trimmer on the tuning condenser and the IF transformer trimmers, they look pretty crusty. I did not want to take a chance with messing with those, so the radio does acceptably well for what it is, so I just decided to leave it alone. Like I previously said, had this been a better example, we would have tried to have fixed this in the correct fashion, but since it's a rust bucket that really isn't economical or feasible for a proper restoration, then we accomplished our goal, and that was to resurrect it good enough to work somewhat okay, and that's where we're going to leave it. If I decide I want a 37-610 Tombstone to do a proper restoration on, I'm sure I won't have any problem finding a better example sooner or later. As far as actual components that I replaced, we replaced 4 electrolytic capacitors, these 2 filter capacitors here, in the power supply, and then there was another filter capacitor up here on the screen bypass screen supply for the oscillator and mixer tube. That one right here. And then there was a 4th capacitor on our bias supply that I don't see on this schematic, but it was on the radio chassis, so I don't know if that was something somebody added at a later time or whether that was a production change. And then we also replaced, where is it? Our plate to grid coupling capacitor on the audio output tube, that guy right there. So had it not been for the open antenna coil that we had to bypass, replacing those capacitors would have got us back in business. Now, all of these other capacitors technically need to be replaced, including this line bypass capacitor. But once again, given the circumstances, I'm not going to bother. I'm not going to be playing the radio that much. If I do play it, and if something fails, we'll worry about it then. But on something like this, well, you shouldn't leave any vintage piece of electronics running unattended anyway, even if it has been restored. But on something like this especially, you don't want to leave it unattended. You want to be there close by in case something goes haywire. You can yank the power real quick.
I said, I wouldn't.
Yeah, even though this cabinet's not in the best of shape,
biologically obese.
the cabinet's probably the best part of it. The chassis certainly is pretty crusty.
In our head. Yeah. I think of just your service to our state. As each has received a gift, use it to serve one another as faithful stewards.
And that speaker, like I said earlier, has some holes in it, but miraculously it's not rattling too badly, so I'm not going to worry about it.
You could call that a form of public service. He never did it for the money. He did it for the love of the student.
Yep.
Lunch. 1 in 6 seniors faces the threat of hunger, and millions more live in isolation. Drop off a hot meal and say a quick hello.
Okay, we'll come back after dark and do a band scan on the standard AM band and see if we get any distant stations, and then we'll try our shortwave band, the one that's active, and see if we can get Brother Stair on this thing. Alright, just for fun, we know that old coupling cap was leaky because it had significant DC on the control grid of the output tube, but let's just see what the old school capacitor tester tells us. Well, the old school capacitor tester is not even giving us an eye opening of any kind. Alright, lowest voltage, which is actually about 50 volts. Oh, yeah. That is basically a short. Even at the lowest voltage, the light is not blinking, it's staying on. And that is a severe case of leakage. Now we know that 6F6 tube is a little tired. It would probably have a little more volume if it had a strong tube in it, but for what this is, that tired 6F6 will do just fine. And I'm sure the other of these red Sangamo capacitors that are in that radio are probably just as leaky as this one, but some of them are not in critical high voltage situations, so it won't be as big of a problem. Okay, it's about 7:20 at night, and we're on the short wave band that's supposed to be active. Let's see what we can get.
A lot of water. Where is it? Well, we know most of it comes from underneath the earth now. It's been trapped inside the earth.
That's some Spanish-speaking station very faintly. Oh, there it is.
Una institución informativa sin rival que continúa evolucionando cada día a la velocidad de la...
There's something.
Some iron, some potted meat, some tuna, some chicken, several bottles of water, whatever the case might be.
Law and the testimony. If your word is sync, is in line, is in symphony and harmony with the word of God. It is the things that you utter to your children, the things that you utter to your business, the things that you say concerning your husband, the things that you say concerning your life and kind.
Sveta. Záverečný výstup im trval 8 hodín. Teplota bola okolo minus 35 stupňov.
On WorldNet Daily, place and food, going protein.
I'm worried that they want to hold together, so we had to break the water again.
Single side band going on there.
Springdale, Arkansas.
That's going to do it for that band. Here's the band that I believe is totally dead, which probably that. No. I'm getting a little something there, but there's WWV very faintly. So it's not totally dead.
Yahoo with congratulations.
Now we're back to standard broadcast. There's some distance coming in.
And the government made more empty promises.
That's probably WWL.
Change up and lead off man is aboard. I mean, look at that. 25, U.S. tax yield, 800-466-9625.
Well, they're not booming in, but we're getting some distant stations on the regular standard broadcast. If this had the proper antenna coil and was properly aligned, I believe this thing would really boom in, even though it's only a 5-tube set.
Saying that as a true homer because I look at who we've played to this point in time.
Okay, and that's about it.
Organized, easy to follow steps that will lead you out of debt, help you build wealth and secure your future. Plus, you'll be inspired by the real life stories from folks just like you who have learned how to put
could
these
stand a hotter output
and change
tube,
their family tree. I've heard
what we got here, what's in there will do okay.
One with money, and so many of them started with this book.
You know, one of my favorite programs, Dave Ramsey, of course, I mean that sarcastically.
Today in the online store at
But
RamseySolutions.com.
that's about all I've got for this set.
22 piece. That's Ramsey Solutions.
We resurrected it, and that was our goal, so we accomplished what we set out for. Now, of course, if I find a nicer version of this radio, and if it needs a part to fix it that's on this chassis, then you know I probably won't hesitate to rob whatever parts needed off of this chassis. Something else I don't think I mentioned, that sub-chassis in the center with the tuning condenser on it is suspended on rubber grommets. Of course, those have long since turned to powder. I believe there is an outfit that sells reproductions of those grommets. Again, if this was a nice example, I would have already ordered some, but I'm not going to do that on this one. Yeah, this is what it is. It's just an old rust bucket that, had I not gotten a hold of it, would have probably just been thrown away. So there you go. So with that said, I hope you got something out of all of this, and thank you for watching, and more to come later, I hope.